In this video, you're going to see how to better understand the self-attention part of the transformers architecture by taking a look at a very simple example using NumPy. In the previous video of this series, I went over how to have a better intuition when it comes to attention in transformers and why I think that the usual way of teaching it is incorrect. I'm going to leave a link in the description down below if you haven't watched that video yet, but the general idea was that the usual way of teaching attention uses a lot of concepts and ideas about attention that are predetermined by what we as humans think about when we hear the word attention and what we do when we say we are paying attention, when in reality the model is not doing anything close to what we do as humans. It's not like the model is choosing to pay X% attention to one word and Y% attention to another word within a sentence. That's simply not what the model does, and in this video we're going to get a better understanding as to why that is. We're still not going to implement the actual attention part of the transformers architecture, but instead we're going to rely on a much simpler example using matrix multiplication and a very simple softmax function. And instead of using two different tensors or arrays in the case of NumPy, we'll just rely on one tensor. I want to invite you to join the Tech with Turis inner circle, a private group for programmers that want to grow their skills and explore new and interesting topics within programming. When you join, you'll get access to weekly group calls for members only, where we'll do everything from teaching classes, have open-ended discussions, and explore new and fun projects. When you join, you'll also get access to a private Discord server where you'll be able to chat with other members and with me. And last but not least, you'll have access to exclusive pre-recorded courses on a range of different topics such as front-end development, back-end development, machine learning, tooling, and much more. To join, go to techwithturis.com/IC. Again, to join, go to techwithturis.com/IC. This is obviously different than the actual implementation of attention within the transformers architecture, but this simpler setup is going to make things a lot easier for us. So right now, just forget about everything that you know when it comes to attention. Forget about words, sentences, tokens, keys, queries, values, and all those concepts that, while important, are not necessary for us to grasp the basic ideas. What we'll do here is pretty simple. We want to initialize a new NumPy array with these values 1, 0, 0.8, 0.2, 0, and 1. So the shape here is going to be 3 and 2. Those are the dimensions, which means that within each one of these rows we have 2 values and we have a total of 3 different rows. Now, one thing that is important to pay attention to is the actual values within this array. The reason I kept this simple is because you're going to see how changing even just one value within this array is going to affect the other values within it. Finally, to calculate the final result, we do a matrix multiplication between x and x transpose. To ensure that each row sums up to a total of 1, we want to pass the scores through this softmax function. And finally, to get the updated values, we want to do a matrix multiplication of weight over x. Like I said, softmax is simply a function that is going to take all of the values within one row and ensure that the sum value will be 1. So now let's take a look at the results with this x array and see exactly what's happening here. First, we print the x array itself, which have the exact same values that we can see here. I've just went ahead and also padded the numbers to be easier to print. And then we can see here the weight. Because we're doing matrix multiplication on shapes 3, 2, and then 2, 3, it means that the final shape will be 3 and 3. So we have 3 different rows. Each one of those rows has 3 items. Finally, we have the updated value, which has the same shape as the original one. If we take a look at this here, we can see that we have 76, 24, 30, 70, 40, and 60. So now let's do an experiment. Let's change this from .8 to .5, and we want to do the exact same thing here. So now when I save, you're going to see everything be updated here. Now, if we pay attention to the updated array, we're going to see that this row was affected, and the final result is 0.5 and 0.5. But the curious thing is that these other 2 rows were also affected by the change done in this row. We now have 0.66 and 0.34, and here the other way around, 0.34 0.64 and 0.66. So let's go back to the previous value really quickly. You're going to see that these values will come back to the original ones, and if we do this again, they're going to all be changed. So what's happening here is the nature of matrix multiplication, and the way we're doing it here, we're able to have certain rows or values within a row affect values within different rows, and obviously values within the same row. Now granted, the actual attention within transformers is much more complicated than this, but it's a great way for us to see in just a few lines that the nature of the architecture is just mathematics. That might seem something very obvious, but like I said in the beginning of this video and a lot more times in the previous one, when learning about attention, we tend to go back to what we know attention is to ourselves as humans. When we pay attention, we focus on one thing, we ignore another, and so when we start learning about these concepts in machine learning, we try to use those same concepts and apply them there. That's very understandable, but it's usually not very productive when we want to learn these concepts that are very mathematical in nature. So if we think about these numbers as an individual token, which obviously is a gross misrepresentation or rather oversimplification, we can see that the reality of what's actually happening under the hood is very simple. Let's imagine that 0.5 would stand for cat, and this here would stand for the actual meaning of the word. So if we were to change this to 0.5 and save, we would have these values change, but also these ones on the top row, and same thing for the bottom row. We can imagine 0.2 would be something like cat inside of a terminal running the cat command, and something like 0.5, what we had earlier, could be cat the actual animal. If we save, now we would have that meaning influence the meaning of the words around it. We could also forget about the meaning of the words for a second and think of this as something that decides how much to change the meaning of other words based on this word itself. Again, these are oversimplifications, and these arrays tend to be much more complex, but you get the meaning. There's nothing here trying to pay more attention or less attention to something. There are just a bunch of matrix multiplications where the meaning of words changes depending on the context, and sometimes that meaning might change more or less, but it's just that there's no one paying more or less attention to a particular word. I'm going to leave a link in the description down below with a link to this very simple example, so you can play around with it, change some of these numbers, and see how that affects the actual output, which I think you should do because, while very simple, this code snippet helps you understand what's happening under the hood when it comes to matrix multiplication and how values can affect their values within an array, which is, at the end of the day, what attention is all about. In the next video, we'll go over how to implement an actual attention mechanism using NumPy completely from scratch. I hope this was helpful to you, and I'll see you on the next one.